Okay, now let's learn about data abstraction. Look carefully at the picture on the slide. This image shows that user only interact with the important functions while the internal process remain hidden. This is called abstraction. For example, when we drive a car, we simply press the accelerator, brake and clutch. We don't need to know how the engine works inside. Similarly, when using an ATM, we simply insert the card, enter the PIN and withdraw the money. We don't know how the ATM communicates with the bank server. Only the necessary information is shown to the user. The internal implementation is hidden. That is exactly what abstraction means. So remember this definition because it's frequently asked in university. Okay. So next, let's understand the abstraction through a Java program. Here we have an abstract class called vehicle. Inside the class, we declare an abstract method named start. Notice that this method has no implementation. Next, the bike class extend vehicle. The bike class provides the implementation for the start method by printing bike started. Finally, inside the main method, we create a bike object and call the start method. The output is bike started. Okay. So the user simply call the start method. They don't know how the method works internally. This is the perfect example of abstraction in Java. So abstraction tell us what to do, but hide how it is done. Okay. In next, we move to data encapsulation. Look at this image on the slide. You can imagine it as a capsule that keeps medicine safely inside. Similarly, in programming, encapsulation keeps data and the method that work on the data together inside a single class. Okay, let me explain with a real-time example. Think about your bank account. Your account balance is not directly accessible to everyone, right? If anyone could change your balance, it would create a serious problems. So instead, you access your bank account only through secure options like depositing and withdrawing money. In Java, we achieve this by keeping variables private and providing public methods to access them. So encapsulation improves security, protect data, and gives us better control over how information is used. Can you think of another example where information is protected from direct access? Can you please type this answer in comment? Next, encapsulation. Now let's understand encapsulation using the Java program. First, we create a class called a student. Inside the class, the variable age is declared as a private. Okay, this means it cannot be accessed directly from the outside the class. To update the value, we use the set age method. This is called the setter method. To read the value, we use the get age method. This is called the getter method. In the main method, we create a student object. We call set age 20 to store the value. Then we call get age, which returns the value 20. So the output is simply 20. This is perfect example of encapsulation because the data remains protected while still allowing controlled access. Okay. So remember this point. Private variable plus getter plus setter is equal to encapsulation. This question is very clear. Practical exams. So far we have learned the four important concepts, right? Object, class, abstraction, and now we are moving to another powerful concept called inheritance. Inheritance helps programmers to avoid writing the same code again and again. Instead of creating everything from scratch, a new class can simplify reuse the features of an existing class. Let's understand this is why and a very simple example. Okay, with a very simple example. So before we look at the Java program, let's think about the inheritance in our daily life. Children inherit many characteristics from the parents, such as eyes color, height, or hair color. Similarly, in programming, the child class inherits properties and methods from the parent class. This saves both the time and effort because we don't have to write the same code repeatedly, right? This idea is called code reusability and is one of the best advantages of the object-oriented programming. Now look at the diagram on the side. You can see the relationship between the parent class and the child class. The parent class contains common properties. The child class automatically receives these properties and can also add its own features. Let's take a simple example. Suppose we have an animal class. Every animal can eat and sleep. Now we create another class called a dog. The dog can also eat and sleep because it is an animal. So in addition, the dog can bark. So instead of writing eat method again, the dog class simply inherits it from animal class. This is inheritance. Can you give any another example for that? Can you please type it? Next, now let's understand inheritance through this Java program. First, we have an animal class. It contains one method called eat, which prints animal eat. Next, we create another class is called dog. Notice the keyword extend. So this keyword tells Java the dog is inherit from animal. Okay. So inside the dog, we add another method called bark. So which prints dog box. In this main method, we create a dog object. Now, the interesting part is the dog can call both eat and bark, right? Even though eat belongs to animal, dog inherit automatically. So, output is animal eat, dog bark. Now we have learned how one class can inherit features from another class. The next concept is polymorphism. Many students find it word difficult because of name. But don't worry, once you understand the meaning, it becomes one of the easiest concept in Java. The word polymorphism comes from the Greek words. Poly means many, morph means form. So polymorphism simply means one thing with a many form. Let me explain with a real-time example. Imagine the word run. A student can run. A computer program can run. A car engine can also run. The word is the same, but the meaning changes depending on the situation. Similarly, in Java, same method name can perform different action depending on the object. Another simple example is the animal. Every animal make a sound, but a dog bark, cat mew, but and a cow moves. Okay, the action is the same, making sound, but the behavior is different. This is exactly called we can call the polymorphism. Can you think any another example where one action has a different behavior? Kindly command it. Okay, so now let us understand the polymorphism using this Java program. First, we have a class called animal. It contains method named sound, which simply print animal sound. Next, we have another class called a dog. Notice that dog extend animal and override the sound method. Okay, instead of printing animal sound, it print dog bark. In the main method, look carefully at this line animal a equal to new dog. Many students get confused here. So the reference variable is type animal, but the object created is dog. When we call a dot sound, Java execute the dog version of the method because the object is actually a dog. So the output is dog box. This is called a runtime polymorphism or a method overriding. Easy example I will tell. Think about a remote control. The same power button works differently for a different device. On a TV, switch on the TV. On a AC, it starts the air conditioner. The button is the same, but the behavior changes based on the device. This is exactly how polymorphism works. Okay. Before moving to the next concept, let's quickly revise the polymorphism. There are two types of polymorphism in Java. The first one is compiler time polymorphism, which is achieved using method overloading. Here the same method name has different parameter list. Okay. The second one is runtime polymorphism, which is achieved using method overriding. Here the child class provides its own implementation of the parent class method. So remember the shortcut: overloading, compile time, overriding, runtime. This is one of the most frequently asked interview question. Okay. Next, object communication. In oriented programming, objects don't work alone. They communicate with each other by calling method and exchanging information. Let's understand this with one online shopping example. Imagine you open Amazon or Flipkart. First, the customer object select the product. Then the order object create the order. Next, the payment object process the payment. Finally, the delivery object delivers the product. Okay. Each object has its own responsibility, but they work together to complete the one task. Okay. Similarly, Java one object calls method from another object whenever needed. So this interaction between object is called object communication. Okay, can you identify different objects involved when you book a ticket on IRTC, reserve or a movie ticket online? Okay, you can type it. Okay, so thank you for everyone watching this video. I hope the session helped you understand the principles of object-oriented programming in a simple and practical way. Okay, so remember OOP is one of the most important topics in Java and is frequently asked in semester examination, coding interviews and placement. So I encourage you to practice the Java program where we discussed today and try creating your own examples using classes and object. Okay, so I have added a quiz also. Attend the quiz. Okay, thank you.